Okay, this is Mr. Hess trying to fix this video. I apologize for no audio on the first time, so let's try this again. Here we can see we're doing 25 psi to millimeters of mercury. So we're going to use psi on top here, and 14.7 psi is equal to 760 millimeters of mercury. When I do the math, and again I'm multiplying these top two together, dividing that answer by 14.7, I get 1292.5, 3 significant digits, so 1290 millimeters of mercury. Number 2, 25 psi to kPas, again 25.0 kPis, 14.7 on the bottom, 101.3 on top. Multiply and divide, I get 172.27. Rounded to 3 significant digits gives me 172 kPas. Number 3, 25 psi to atmospheres, 25 psi, 14.7 on the bottom, 1 atmosphere on the top. Do my math, I get 1.7006. Round to 3 significant digits, 1.7 atmosphere. Number 4, 200.0 is 4 significant digits. You can see that this final 0 here, that is the final 0 after decimal place, so that makes these two also significant. Take 200 kPa, 101.3 on the bottom, 14.7 on the top. Do your math, you get 29.022. 4 significant digits, 29.02 psi. For number 5, same way, 200 kPas, converting to millimeters of mercury, so 760 on top, 101.3 on the bottom. I come up with 1500.49. So if I'm doing 4 significant digits, I go 1, 2, 3, 4, draw my line, look at my 4. 4 means I leave that 0 the same, so that gives me 1500, but that's only 2 significant digits. So therefore, I'm going to take my decimal place from here and move it over 1, 2, 3 places to give me 1.500, 4 significant digits, times 10 to the 3 millimeters of mercury. Number 6, 200 kPa to atmospheres. 200, 1 atm on top, 101.3 on the bottom, 1.9743, so 4 significant digits, 1.974 atmospheres. Number 7, again I got this 1 liter balloon filled with helium at 1.20 atmospheres. If the balloon is kept at a constant temperature and is squeezed into a 0.50 liter beaker, it doesn't burst, what's the new pressure? So P1 is 1.2 here, V1 is here. T's are constant, so I can just ignore them. Trying to find P2, and my V2 is 0.5. So therefore I can cancel out these T1 and P1. I want to get P2 by itself, so I'm bringing V2 down here. So therefore P2 is P1 V1 over V2. Plug in my numbers, 2.40 atm. 3 significant digits, because all the numbers I have are 3 significant digits. Number 8, I have my numbers here. You can see that here is my V1, P1, T1. So you see I put those there. I want to find volume, so volume is a question mark. When the temperature goes to 100 and the pressure rises to 15. Now again, right off the bat, you should notice that I have ATMs here, and I have millimeters of mercury here. I can't have different pressure units. I have to make them the same. So therefore, I'm taking that 15 atmospheres, converting it to millimeters of mercury. 15.0 times 760, that gives me 11,400 millimeters of mercury. I'm then going to solve this equation for V2, get V2 by itself. So therefore, T2 goes up, P2 goes down, and I get this equation. V2 is P1 V1 T2 over P2 T1. Plug in my numbers, and I don't know if you can see this. I can scroll down here a little bit. There we go. that V2 is equal to 12,943. I only need two significant digits because 120 is only two significant digits. That 0 is a final 0, but it's not after a decimal place. 4 for 900.0, 3 for 0.00. That is a 3 significant digits. Even though I know it doesn't follow the rules, it's still 3. And that's 100.0, that's 4. So therefore, 13 will be my answer. Number 9. I got STP, that's standard temperature and pressure. That means 1 atmosphere, or whatever, 101.3 kPa, 14.7 psi, 760 millimeters of mercury. And standard temperature, which is 273 Kelvin or 0 Celsius. So V1 is 400, T1 273 or 0, and pressure I chose 101.3 because they use 404 kPa as my P2. So I want to keep those units the same. Keep the units the same. I'm trying to find T. So here's my equation. I want T2 on the bottom. I want to find T2, right? So my first step is I just flip these things over so that T2 over P2 V2 equals T1 P1 V1. Just the reciprocal, right? I can do anything to either side as long as I do it to anything to one side of the equation, as long as I do it to the other. Getting T2 by itself, I'm simply going to bring these P2 and V2 up on top. So T2 is T1 P2 V2 over P1 V1. Plug in my numbers. Oh, I'm moving things around here. Plug in my numbers, and I get 1088.76, 3 significant digits, so 1090 Kelvin or 816 Celsius. Last but not least, carbon dioxide at STP. Its volume is 500, so therefore here's my 500 is V1, 273 is my STP, and because my P2 is PSI, I chose 14.7 as P1. It changes to 25, and the temperature goes to 75. What's the new volume? Using my equation, I want T2 to go up, P2 to go down to get V2 by itself, so therefore there's my new equation. Plug in my numbers, and I get 374.769. Rounding to 3 significant digits gives you 375. If you have any questions, again, please feel free, text, email, Schoology, let me know.